Lesson 8, I will use the area model and multiplication to show the equivalence of two fractions. In Lesson 7, we talked about how you can use the area model and multiplication to show the equivalence of two fractions, and we're going to continue that again in this lesson. Move on to our problem set. I want you to go ahead and write your name at the top, and I want you to notice that it tells us right here that each rectangle represents one whole. So that's why none of these area models are labeled as one whole, because it tells us right here that they all equal one whole, so we don't have to label that every single time. The shaded fractions have been decomposed into smaller units. Express the equivalent fractions in a number sentence using multiplication. The first one has been done for you. So you can take a look and you can see that on the first one, it started out as 2/3, and we multiplied the numerator and the denominator by 2, and we got our equivalent fractions of 4/6. Okay, so this is a good example of what we're expected to do. All right, so we're going to do the same thing over here. We started with 3/4. And then they took the numerator and the denominator and they multiplied it by the same number, and we ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. So in that case, we would have to multiply the numerator and the denominator by 3 in order to get an equivalent fraction. All right, let's take a look at C. Okay, so we began with 4/5. I'm actually going to write this over here because I'm kind of a little squished at the bottom. So I started with 4/5, and we took 4 and we took 5, and we multiplied the numerator and the denominator by the same number, and we ended up with 1, 2, 3, 4, 5, 6, 7, 8 out of 10. And you can see right here that they decomposed this in half. So they doubled the number of parts. So they multiplied the numerator and the denominator by 2. So 4/5 is equal to 8/10. Why don't you try to do D by yourself and then come back and see how you did? All right, so hopefully you paused the video and you attempted to do this by yourself. The worst thing that happens is you don't get it right, and that's okay. You learn a lot by trying to do this by yourself. All right, so I began with 1, 2, 3, 4, 5 out of 6. I'm going to put it over here because I have more room. I began with 5/6, and I can tell that I doubled the number of pieces because I divided them in half. So in that case, I'm going to multiply the numerator by 2, and I'm going to multiply the denominator by 2. And instead of 5/6, I now have 10 out of 12, and I can count and see if that's correct. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 12. Okay, so the bottom has a little bit of different directions. Decompose the shaded fractions into smaller units as given below. Express the equivalent fractions in a number sentence using multiplication. All right, so right here, this is divided into 5 parts. The directions say decompose it into tenths, so that means that we are going to divide it in half one time like this. Now I have to express the equivalent fractions in a number sentence using multiplication. So I began with 3/5, and I took the numerator and the denominator, and because I doubled the number of parts, I'm going to multiply both of these by 2, and that gives me 6 out of 10, and I can go back and count 1, 2, 3, 4, 5, 6 out of 7, 8, 9, 10. So I had 6 out of 10. All right, so this time it's divided into 5 parts. So I want to decompose it into 15 parts. So that means I'm going to triple the number of parts. If I'm going to triple them, I'm going to have to decompose this twice. So now I've got 3, 6, 9, 12, 15. So I began with 3/5, and I multiplied the numerator and the denominator by 3. So now, instead of 3/5, I have 9/15. All right, now we have to draw area models to prove that the following number sentences are true. So first I'm going to draw an area model to represent the first one. So it says 2/5 is equal to 4/10. So I'm going to start by drawing my area model. I'm going to do it in this space over here. And I have to make this represent 2 out of 5. So I have to divide this into 5 parts. So that means I have to draw 4 lines. So I'm going to say 1, 2, 3, 4. Okay, so now I've divided it into 5 parts. I'm going to make this actually reach the top here. So I've got 1, 2, 3, 4, 5, and since it's 2/5, I have to shade 2 out of 5. So let me get my highlighter here. I'm going to shade 2 out of 5. Now I'm trying to prove that this is the same as 4/10. So look at what happened to the number of parts. They doubled. So that means I've only got to decompose this one time, just like this. So now I have 2/5 is equal to 4/10. It does not say that I have to use multiplication. It just says draw the area model. All right, so let's try B. Okay, so again, we're going to begin by illustrating 2/3. So I'm going to go ahead and I'm going to make my area model and I'm going to divide it into thirds. So that means I'm going to divide this with 2 lines. And I've got to shade 2 out of 3, so I'm going to get my highlighter because remember when you shade, it's really important that you can still see where you divided your area model. If you shade it too dark so that you can't see your lines of division, it's not going to make it as effective. You're going to have a hard time reading it. All right, so now I've got 2 out of 3. Now it says that I need to make these 12s, so it didn't double. Look at what you'd have to do to go from 3 to 4. It didn't triple, it actually quadrupled. So that means that I have to divide each of these into 4 parts. So that means I'm going to have to draw 3 lines like this. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8 out of 8, 9, 10, 11, 12. Okay? All right, why don't you try to do C by yourself and then come back and let's see if we did it the same way. All right, so hopefully you tried to do this one all by yourself. I kind of messed up here with my line, so I'm going to go ahead and get in here and delete this line. So I'm going to start with my area model. Hopefully you did too. And the first thing that you're going to do is you're going to try to show 3, 6. So we're going to go ahead and make my lines, and I'm going to divide this into 6 parts. So I'm going to start by dividing this in half, and then I'm going to divide each half into thirds. That way they'll be a little bit closer to being the same size. They won't be perfect, but they'll be a lot closer. All right, so now I'm going to go back and count and make sure that I do have 6. It's really important that you do that. 1, 2, 3, 4, 5, 6. So I do have 6, and it says that I need to shade 3 out of 6. I'm going to come over here and I'm going to shade 3. Okay, so now I have 3 6s, and I have to prove that this is the same as 6 12s. Well, I'm going from 6 parts to 12 parts, so that means that it doubled. So to show that it doubled, I only have to decompose it once, just like this. So now instead of 6 parts, I have 1, 2, 3, 4, 5, 6. 6 out of 6, 7, 8, 9, 10, 11, 12 out of 12 parts. All right, try to do the last one all by yourself. Okay, pause the video and then come back and let's check and see if we did it the same way. Okay, so let's begin by drawing our area model to represent 6s. So again, I'm going to divide this into half, and I'm going to divide each half into thirds, just like I did the last one. And then I'm going to shade 4 out of 6. So let me get my 5 lines drawn, and then I'm going to go back and count and make sure that I do have 6. So let's count, make sure we have 6. 1, 2, 3, 4, 5, 6. And I've got to shade 4 out of 6. I'm going to go ahead and get my highlighter, and I'm going to shade 4. All right, so now I have 4 6s. So again, I'm decomposing these into 12s. So when I look at my number of units, I went from 6 total to 12 total. So all I did was double. So I'm just going to divide this in half, just like I did the last one. Okay? All right, so let's just keep going here. All right, now it says use multiplication to rename each fraction below. So we could do this a lot of ways because it doesn't give us any direction. But we just know that we have to take the numerator and the denominator and we have to multiply them by the same number. It doesn't matter what number it is, we just have to multiply them by the same number. So for A, I think I'm going to go ahead and go easy, and I'm going to multiply both of them by 2, which is going to give me an equivalent fraction of 6/8. So for B, I've got 4/5, and I think this time, just for fun, I could multiply this by 2 just like I did the last one, but I think I'm going to go ahead and multiply this one times 3. And now my equivalent fraction is 12/15. So why don't you try it with 7/6? pick a number, any number, doesn't matter. I wouldn't pick a number that I didn't know how to multiply. That was going to cause me a lot of work. But pick a number and multiply the numerator and the denominator by the same number. The only number that you cannot choose is 0 or 1 because that would not give you an equivalent fraction. All right, so I think I'm going to choose 4. And now I have 28/24. And you can see that this is an improper fraction or greater than 1 because I have more parts than I have, but that's okay. All right, the same thing here. I'm going to do 12/7. I think this time I'm going to just multiply times 2, keep it kind of easy, and I'm going to end up with 24/14 as an equivalent fraction. All right, so it says, determine which of the following are true number sentences. Correct those that are false by changing the right-hand side of the number sentence. Okay, so first of all, I want to determine, is 4/3 equal to 8/9? Remember, in order for these to be equal, that means that I should be able to multiply the numerator and the denominator by the same number to get 8/9. But if I'm going to get 8 on the top, I have to multiply times 2. And to get 9 on the bottom, I'm going to have to multiply times 3. So this is not an equivalent fraction. So I'm going to call this false. So it says to correct the right-hand side. So this is the right-hand side. So I can either change the numerator or the denominator. Well, the denominator, if we want to change the numerator, the denominator was multiplied times 3, so I would have to multiply the numerator times 3, which instead of 8/9 would give me 12/9. I could also have chosen to change the denominator. So since the numerator was multiplied times 2, I could have multiplied the denominator times 2 and made this 8/6. Either way, it was incorrect and now it is correct. Let's try one more together. All right, so I've got 5/4 is equal to 10/8. All right, so I want to see if I can multiply the numerator and the denominator by the same number to get 10/8. So to get from 5 to 10, I multiply times 2. To get from 4 to 8, I multiply times 2. So yes, this is true because I multiplied the numerator and denominator by the same number and I got the fraction that it said. Why don't you try C? Decide if you think that this is true or false. Pause the video and then come back when you are finished. All right, so hopefully you paused the video and you attempted to do this by yourself. So here's the way I'm going to work this out. I'm going to see if I can multiply the numerator and the denominator by the same number and get 12/10. Well, to go from 4 to 12, I have to multiply times 3. To go from 5 to 10, I have to multiply times 2. Because these are not the same, then this is false. So now I have to correct it. You could have corrected it by changing the numerator. We could say, okay, we're going to multiply the numerator times 2. So instead of having 12/10, that would give you 8/10. So you could have changed the numerator to 8 and made it 8/10. Or you could have said, well, I'm going to keep the 12 and multiply the the denominator by 3, which means you would have ended up with 12/15. Either one of those would have been correct. All right, try to do D all by yourself. I want you to pause the video and do not guess. Try to work it out because you do have a 50-50 chance if you guess, but I want you to really try to figure it out, or else, even if you get it right, that doesn't really mean anything. Pause the video, think about it, put what you think, and then come back. All right, so let's work this out. So I have 4/6, and basically I just want to see, can I multiply the numerator and the denominator by the same number to get to 12/18? So to go from 4 to 12, I have to multiply times 3. To go from 6 to 18, I have to multiply times 3. So since this is the same number, then this is true, and I don't have anything to correct. Okay, so today we worked a little bit more on find equivalent fractions using multiplication. This is a continuation of what we did in lesson 7. The only difference is we worked with numerators today that were not unit fractions. They were not just 1. We chose numbers that were greater than 1, and it was still the same. You just have to multiply the numerator and the denominator by the same number to come out with an equivalent fraction.